So the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. Okay, so today we're going to be covering section 6.1. And we'll get to that eventually, but I have a few things that I want to mention or remind you of. And as we go along, I'll probably remember some other pieces of information that may be useful to you as well. This quarter, the Math Center will be open, available through Zoom. And so here is the Zoom ID for that and the hours, Monday through Friday, 10 a.m. to 4 p.m., Monday through Thursday, 6 through 9 p.m. I'm not sure if there is going to be, if the Math Center is open on campus as well. I heard talk of it earlier on, but don't know. You could check on the Zoom meeting and ask them if any of you want to go in there in person. Again, I don't know if that's going to be available. Let's see, what else do I want to tell you? I just want to remind you that I don't use Canvas, so don't look there for any messages. I'm already getting students emailing me saying I can't find it on Canvas, and you won't. Also, don't send me messages through WebAssign. I don't look there for messages. Email me at my school email. Okay. Now, also, during Zoom meetings, there's a way to send messages to people. I don't look for the messages. I've got enough going on just teaching the class. So if you have a question during the meeting, just, jump in and say, hey, Mr. Mayo, wait a minute. I've got a question about that. Happy to deal with that with you. Okay. Also, I noticed only about half of the people that are registered for the class through YBC are registered through WebAssign. So if you're having issues with that, you can either email me or show up to my office hour at 1:15, that Zoom meeting this afternoon, and I'll deal with you then. Anyway, there you have that. So let's go ahead and get started with section 6.1. Okay, now if you got the textbook, it should be there in the textbook, or there's an online ebook that you can also access if you want as part of WebAssign. But I'm just going to go ahead with the lesson, and as I say, if you have questions, just say, hey, I've got a question, and we will approach or deal with that question. Okay. So let's go here. So here we are in section 6.1. It's called the greatest common factor and factoring by grouping. Okay. So first of all, let's kind of review the idea of a GCF, a greatest common factor. The following questions, it says, find the greatest common factor of each list of numbers. So 6 and 10. The easiest way, or perhaps the best way to do this, is to do the prime factorization of each number. 6 is 2 times 3, and 10 is 2 times 5. So having them in this form, we can see that the 2 is common to both. So the greatest common factor would be 2. Now, problems like this that are small and perhaps it's easy enough, you can just look at it and see that the greatest common factor is 2. You don't have to do the prime factorization to get the results, but it can be helpful when the problems are more difficult. Let's take a look at another one. Hang on a second, I'm going to move this over. Come on. Trying to move it so it's not blocking the screen. There we go. Okay. All right, so find the greatest common factor of 10 and 15. 10 is 2 times 5, 15 is 3 times 5, so the greatest common factor is 5. Any questions about that or how that's working? Okay, how about the greatest common factor of 16, 24, and 48? Well, 16 is 4 times 4, or 2 times 2 times 2 times 2. 24 is 4 times 6, or 2 times 2 times 2 times 3. 48 is 2 times 24, or 2 times 2 times 12, or 2 times 2 times 2 times 6, or 2 times 2 times 2 times 2 times 3. Okay. So what's common to all of them? A 2, a second 2, a third 2, and that's it. So the greatest common factor is 2 times 2 times 2, or 8. Okay. Any questions about that problem? All righty. How about this one? 28, 35, and 21. 28 is 2 times 14, 2 times 2 times 7. 35 is 5 times 7. 21 is 3 times 7. The greatest common factor is just the 7. All right, now, how about the following situation? We've got 9a and 21. What's the greatest common factor here? Well, 9a would be 3 times 3 times a, and 21 is 3 times 7. So the greatest common factor would just be 3. Any questions there? Oh, okay. How about this? 18r, 27r cubed. Well, 18 is 2 times 9, or 2 times 3 times 3, and then times r. 27 is 3 times 9 times r cubed. 3 times 3 times 3 times r times r times r. So what do they have in common? A 3, another 3, and an r. So the greatest common factor is what? 3 times 3 times r, or 9r. All right with that?
I had a question.
You bet.
Okay, I get the like the main focus. It's kind of just I get lost kind of like where you group below that. Like you know how you do 2 times 9, 3 times 9 r cubed, and then you kind of break it down more. That's where I kind of got lost.
Okay, so your question is what's going on here?
Yeah.
All right, so what I'm doing is prime factoring that number, breaking it down into numbers that are multiplied together, so factors that are all prime numbers. A prime number is a positive integer greater than 1, whose only divisors are itself and 1. So 18, it's even, so I took a 2 out. 9 is 3 times 3, 2, and 3 and 3. Those are all prime numbers. So I'm breaking it down into its prime factored form.
So 2 times 3 times 3 times r would then give you 2 times 9 times r?
Yes, or 18 times r.
Oh, okay. So the 2 times, so 3 times 3 is the 9, right?
Yes.
And then why did we multiply by 2?
Why didn't I?
No, why did we?
Okay. Let's do this. Let's go back through this again. Okay. Let's see. What did we have? We had 18r and 27r cubed. So the number part of this term, the 18 is 2 times 9, right?
Yeah.
2 is a prime number, but 9 is not a prime number. So I'm going to break that 9 down into 3 times 3.
Oh, okay. That makes sense.
All righty. And then 27, 3 times 9, 3 times 3 times 3, and then r cubed, r times r times r. Then I look across and say, okay, what's common to both of these? 2 3s and an r. So greatest common factor is 9r. Okay with that?
Yeah.
All righty. let's go on then. I have the following: 15 c squared d to the fourth, 10 c squared d, and 40 c cubed d cubed. I just thought of some things I wanted to tell you. Did I talk about, to remind you, I don't use Canvas and don't send messages through WebAssign? Did I say all that in this class?
Yeah.
Okay, sorry. I had another class this morning right before this, and so I kind of like, I don't remember what I said when, and I'm confused. Okay, all right, great. Also, I'm seeing people keep sending me text messages. I'm not going to respond to them during class. So if any of you are doing that, but I will get to those later. All right. So 15 c squared d to the fourth would be 3 times 5 times c times c times d times d times d times d, right? If I broke it down all the way, 10 c squared d would be 2 times 5 times c times c times d. And 40 would be 2 times 2 times 2 times 5 times c times c times c times d times d times d. And I did this very quickly because what I want to get to is this, okay? Looking at just the number part of it and not worrying about the variable part. So focusing on that and that and that. What's the greatest common factor of those three rectangles? What's inside of there? It's just a 5, right?
Yeah.
Okay, now, I really don't need to take the c squared d to the fourth and the c squared d and the c cubed d cubed and expand them. What I can do is I can say, well, let's look at the c's, okay? What do they all have in common? They all have in common the lowest power of c that's up there. So c squared. And then let's take a look at the d's. What do they all have in common? The lowest power of the d, so just d. So rather than expand all of this, all I need to do is take the lowest power of each variable that's up there. Does that make sense?
Yeah.
So you don't really need to expand it like this and this and this. I mean, you can, but all right.
Okay.
Let's see here. How about this? 2 times the quantity y minus 1 and 5 times the quantity y minus 1. Well, the factors of that first expression are 2 and then the quantity y minus 1. The factors of the second expression are 5 and then the quantity y minus 1. So the greatest common factor is y minus 1. Okay with that?
Yep.
All right, excellent. Okay, now it says factor out the GCF, or factor out the greatest common factor. That's supposed to be a plus sign. Okay, what we're going to do, let's see. Suppose I had the following. Okay, let's say I had this expression and I was going to use the distributive property. I would get 18x plus 24, right? What I'm going to do here is go backwards. So I'm going to undistribute, if you will. Instead of distributing the 6, I'm going to take out a 6. Why take out a 6? Because, again, if we go back and look at this term by term, 18x is 2 times 3 times 3x. 24 is 2 times 2 times 2 times 3. So we see that there is a 2 times 3, or a 6, common to both, and a 3x plus 4 left over. Do you see what I did there? Now, obviously having this right here makes it easy for me to see where this is going, but I won't always have that right there. I'm just trying to show you that factoring is like undistributing, so to speak, in this context. And if I need to go through all of this to see what to do, I can do that. But if I don't, if I can just eyeball it, so to speak. So for instance, let's say I just have this problem and it says, take out the greatest common factor. And I go, oh, I can take a 6 out of both of those. Well, what's left over? Well, if I have 18x equal to 6 times something, oh, 3x. And 24 is equal to 6 times 4. Okay. Now, to make sure I've done that correctly, that I've factored it correctly, 2 things should happen. One, if I distribute, I should get back to where I started. And secondly, there shouldn't be anything common in there other than a 1. Let me expand on that a little further. I might look at that and say, oh, you know what? 3 goes into 18x and into 24. So I'm going to take out a 3. Now, the statement I have, this is equivalent to what I started with, but it's not correct in that I didn't take out the greatest common factor. I took out a 3, but I see that I could still take out an additional 2 out of the 6x plus 8. So that's how I know that I didn't take out the biggest amount I could. Likewise, I might have said, oh, I can take out a 2. But I can take a 3 out of both of those. So the correct process would be to take out the 6, because we want to take out the biggest quantity that we can, the greatest common factor. Any questions about that? All right, let's take a look at another one. A squared plus 9a. Too much space there. A squared plus 9a. So what's the greatest common factor? A. What's left over? A plus 9. If I distribute it back together, I get this, and there's nothing common there except a 1. Any question there? All right. 27a squared minus 9a plus 9. Well, 27 minus 9 plus 9, what's common to all of those? The 9. A squared, A, no A at all. Well, the lowest power of A there is none at all, so I can't take out an A. It's got to be common to every term. There's no A's in the last term, so I can't take out an A. Okay.
Quick question.
Slow answer. What?
So I know we chose 9, but I know 27a squared doesn't have a 9.
Oh, but it does.
Oh.
See it?
Oh, I see. Okay.
Aha. Okay. So we're going to have a 9, and then we're going to have a 3a squared minus a plus 1.
So are you just distributing it right now then?
Undistributing it?
Yeah,
Sure.
Is that what you're doing?
Sure.
Oh, okay.
I want to talk about Hansel and Gretel. Okay.
I have a quick question on
Oh,
that
yeah, sure,
last one.
Lindsay. What?
So I did it and I did 3a squared minus 1a minus 1. Would it be wrong if I did 1a?
Okay, why do you have minus 1?
Oh, because I wrote it down minus instead of plus.
Okay. Now,
So that's plus.
But you bring up a good point. So you put a 1 there, right?
Yeah.
Technically, it isn't wrong.
Okay.
It also isn't necessary to have the 1. Unfortunately, in WebAssign, it marks it wrong. Now,
Okay.
if I see your answer on a test and it's marked, I always look at all the wrong answers students have a test, and I see that you put a 1 there, and that's why I marked it wrong. I'm going to give you credit for it, but just suffice it to say, it will be marked wrong. WebAssign will say, no, don't put the 1 there. It isn't
Okay.
wrong. It's just, it's a waste of ink or pencil or whatever. Okay.
All right.
Now, but I have another scenario when I said I wanted to talk about Hansel and Gretel. Okay. Does anybody know the story, the fairy tale, Hansel and Gretel? And I'm not talking about Hansel and Gretel, the witch hunters, or, not that movie. But so there's these two kids. They're gonna go into the woods on a hike or something. I don't remember, but one of them says, well, we got to be careful. We might get lost. So they have this brilliant idea. Let's leave a trail of breadcrumbs, and then we can follow that back out of the forest, right? So the idea was good, but breadcrumbs not so good. Why? What happened? Anybody? Nobody knows?
No, I don't.
Birds came along and ate the breadcrumbs. So they got lost, and then they end up at the witch's house where it's all made of candy and they eat it and blah, blah, blah. Anyway, but the point is they had a good idea to start with, and that was to leave a trail to get back. But unfortunately, they should have used something other than breadcrumbs. Now, what does all that have to do with math here this morning? We need to leave a trail so we can get back to where we came from. And what do I mean by that? A common mistake is for students to do this. And they say, well, I've already got the 9 there, so I don't need to put anything inside of the parentheses. But that's not true. You do need to put the +1 because you need to be able to get back there.
That's +9, right?
What's +9?
Oh, no, I'm saying you added the +1 because when you distribute it, it gives you.
Yes, yes, absolutely. Okay, so, but don't be like Hansel and Gretel. Don't use breadcrumbs. But you need that +1 there. So you don't need the 1 there because -a is equal to -1a, but you do need a +1 there so that when you distribute, you can get back to where you started. All right? Okay, so part of your assignment is to read the story about Hansel and no, I don't have to do that. All right, let's see here. How are we doing for time? Let's look at one more of these. 3x squared y cubed minus 9x to the 4th y cubed. So the greatest common factor of the 3 and the -9 is a 3. The greatest common factor of x squared and x to the 4th is x squared. The greatest common factor of y cubed and y cubed is y cubed. So there's my greatest common factor, 3x squared y cubed. Inside the parentheses, I need a 1 and a -3x squared, right? Because this times this is going to give me that, and this times this is going to give me that.
I'm kind of confused. I know that you said the 3 times the -3x squared. I'm just confused how we got. Okay. Oh, okay. I'm sorry.
It's okay. Sometimes you just got to talk it out to see it. That's okay. You good? Everybody good?
Yeah.
Why? Because remember, if you're multiplying, and this goes back to chapter 5, which was from Math 85, which some of you took and some of you probably just tested right in here. When you're multiplying 2 powers with the same base, you add the exponents. So that x squared times x to the squared is where I get the x to the 4th. Is that what you were wondering about, Leah? Okay, anyway. All right, we good?
Yeah, sorry, I couldn't unmute my computer,
Okay.
but that makes sense.
It's okay. All right. This next one says factor out -1 from each polynomial. So I'm going to take out a -1. So -1 times what? A positive x would give me -x, and -1 times a positive 2y would give me -2y. So I'm factoring out a negative. Distributing a negative changes the sign of each thing inside. Factoring out a negative changes the sign of each thing inside. Now, you could also write it like this, because that 1 is implied here, but either way would be.
So So like, let's say the x was positive, then we would do just 1 times x instead of doing it as a negative.
Okay, well, the directions for this problem specifically said factor out a -1. So if you were to do that, it would look like this.
Oh, okay.
Now, they won't typically give you a problem like that and tell you to factor out a -1. What they're trying to do is to get the leading term to be positive, because where we're going in this chapter, factoring, it's easier to continue the factoring process if you have a leading term that's positive. So they wouldn't tend to ask you to do that with this problem.
Oh, okay.
Let's look at some more of those. Let's see here. -t² minus 9t plus 1. So factoring out a -1, we're going to have t² plus 9t minus 1, because that's going to give you that, and that's going to give you that, and that's going to give you that. We okay with that? Notice this was negative because negative times negative is positive. Questions there? All right. Oops. As I said, it's good to have the leading term positive. So since here we have the leading term is negative, let's factor out a negative. But then the greatest common factor of 4 and 6 would be a 2 and then an a. So then inside we'd have 2a minus, oh no, 2a plus 3. How do I know if this is correct? That would give me -4a² minus 6a. And there's nothing common inside the parentheses other than just a 1. We okay there? All right, I see that thumbs up. I'll take it. All right, now, here's where things get a little more interesting. Let's see here. We have y times x plus 2 plus 3 times x plus 2. And it says factor. All right. The first term is made up of 2 factors, y and the quantity x plus 2. The second term is made up of 2 factors, 3 and the quantity x plus 2. So what's the common factor? What's the greatest common factor? It's x plus 2. But what's left over in parentheses would be the y plus 3. So taking this and factoring it, you would get that. Any questions how I got from here to here?
No.
All right, let's take a look at another one. R times the quantity t plus v plus 3 times the quantity t plus v. Well, here, the greatest common factor is t plus v, and the leftovers are r plus 3.
Okay, it looks, when you write it out, it looks complicated, but after you explained it, it's fairly easy.
Well put, I agree. It seems complicated, but when you see what's going on, it's not bad. So, Chinese food, and I'm talking about like you go to Safeway and go to their deli counter and get some Chinese food. Now, first I need to say, I had some students from China once, and I asked them where they go to get good Chinese food, and they said Seattle, but that's another story. Chinese food, there's typically two things if you go to Safeway and get it. There's the takeout, and when you're done, anything you haven't eaten, you put in the fridge, the leftovers, and it sits there and you forget about it. And later you have a biology experiment going on with all the mold, and then you throw it away. But my point is, there's the takeout and the leftovers, okay? This is the takeout because we took it out, and this is the leftovers. Does that make any sense?
Yeah.
Okay. In case you're wondering, I have a stupid story for just about everything to try and get you to remember it. So there you go.
Anything helps.
Okay. Here's another one. M times the quantity P minus Q minus 5 times the quantity P minus Q. So what's the greatest common factor? What am I going to take out? P minus Q. What's left over? M minus 5. All right with that?
Yeah.
Any questions? Okay, we're going to wander into the deep end now, so get your life jackets on. Okay. Here we have an expression with 4 terms. The directions say factor by grouping. But before we do that, let's look at those 4 terms. Is there any number or any variable that's common to all 4 terms other than just the number 1? And the answer is no, there isn't. But let's break it up into 2 groups of 2. So we're going to factor this thing by grouping is what it's called. Now, take a look at the first 2 terms, the 2x plus the 2y. What's the greatest common factor there? It would be a 2, and the leftovers would be x plus y. You okay with that? All right. Now, let's take a look at the second 2 terms, the ax and the plus ay. The common factor there is a, and the leftovers are x plus y. Now, I'm missing something. There needs to be something right there, and that would be what? The plus sign. Okay. Now, this problem is just like the previous 2 that we did. There's the takeout, oops, and the leftovers.
So that equation you wrote right above of what
Wait,
you're doing.
stop, hold it. It's not an equation, it's an expression.
Okay, the expression,
Yes.
would that be the final answer?
This?
No, the one above it.
Nope. This is the final answer.
X.
So we took out the greatest common factor here and here, and then we took out the greatest common factor of that.
Your little lines kind of got me confused. I'm sorry. I'm confused on the last expression.
How I got it?
Yeah.
Okay. What's the greatest common factor of this expression? X plus y. That comes out. What's left over? 2 plus a.
Oh, okay.
So that last step was the same thing that I did here and here.
Right.
Here.
Oh, okay.
All righty. We're just expanding our horizons, getting things more and more complicated. Woohoo! How fun is this?
Yay.
All right. Okay. Bx plus bz plus 5x plus 5z. We have 4 terms. We are going to factor by grouping. There is no greatest common factor of all 4 terms other than a 1, and writing it as 1 times all of that isn't going to do anything for us. So we're going to break it up into 2 groups of 2, and we're going to factor by grouping. Okay? The greatest common factor of the first 2 terms is b, and the leftovers are x plus z. The greatest common factor of the second 2 terms is 5, and the leftovers are x plus z, and it has to be a plus 5. So we've just taken an expression with 4 terms, and now we've broken it down into 2 terms, because each of those 2 terms is a product. So here's a term and here's a term, okay? Now, what's the greatest common factor of these 2 terms? Well, x plus z, and the leftovers are b plus 5. So now it's 1 term, which is a product made up of 2 factors, et cetera, but it's all one big term. So this is your final answer. How do you know whether it's correct? Well, we go back to chapter 5, multiplying this out, foiling it together, we get bx plus 5x plus bz plus 5z. Let's see, bx, 5x, bz, 5z. So there's your final answer. How we doing? All righty, let's keep going. Let's see here. 12ab minus 4ac plus 3db minus dc. Well, let's see. Yep, there's nothing common to all of them except a 1. So let's factor it by grouping. The greatest common factor of the first 2 terms is 4a. The leftovers are 3b minus c. The greatest common. Go ahead. Okay.
Why did we do 4? Oh, is it because 4? Okay, I'm sorry.
It's okay. You got it?
Yeah.
All righty. The greatest common factor of the second 2 terms is d, and the leftovers are 3b minus c. And this is going to have to be a plus sign there. But now the greatest common factor of these 2 terms is 3b minus c, and the leftovers are 4a plus d. Any questions there? All right, let's go on to another problem. Tx plus tz minus x minus z. There is no greatest common factor of all 4 terms except a 1, which doesn't do anything for us at this point. So we'll break it up into 2 groups of 2. The greatest common factor of the first 2 terms is t, and the leftovers are x plus z. So far, so good? Okay, now, What's the greatest common factor of the second two terms? Is it a 1 or is it a -1? Before we answer that question, let's go back. Let's see here. Let's go all the way back here. Okay. Notice for this to work, this quantity and this quantity had to be the same, didn't they? Because if they weren't identical, I couldn't have pulled them out, right? Same thing here. This quantity and this quantity had to be the same, because if they weren't identical, I couldn't have pulled them out. This quantity and this quantity have to be the same. Oh, this quantity and this quantity have to be the same. This quantity, this is getting old, isn't it? And this quantity have to be the same. Well, so it seems to me that this quantity and that quantity have to be the same for this to work. So that means this has to be an x plus z. So what do I need here? Do I need a +1 or a -1 to get this thing to work?
Do you need a -1?
You need a -1. Because if I took out a +1, this would be a minus and that would be a minus. Those wouldn't match and we'd be stuck. So that's how I know what to take out, because I need those to match. In fact,
So-
here, go ahead, what?
Oh, I tried to solve it, but I can wait.
Okay, now, I would go so far as to say this. After you've done the first one, don't look up, look over. Don't look up, look over. Look over here and clone that, because those need to match. Then look up and say, oh, it's got to be a -1, not a +1. Now I can go on and do the next step, x plus z, t minus 1, and I'm done. Okay. Let's take a look at another one of those. Are you ready? Not quite. Okay.
So on that last one, would it be wrong if I just did negative times x plus z? Or does it have to be a -1?
Right there.
Yeah.
Okay. It would be correct to just put a minus sign, but in the next step, you've got to have that 1. So I would recommend you put it there to remind you that you need it in the next step. Does that make sense?
Yeah.
Okay. It isn't wrong to leave it out, but you might forget to leave it out in the bottom step, and it has to be there. Okay, now, here's another one. Let's see. 9p minus 9q minus mp plus mq. There's nothing common to all 4 other than a 1, so I'm going to use grouping. Oops, I'm supposed to be red, doesn't really matter. Greatest common factor, the first one is 9, and I have a p minus q. So don't look up, look over. I need a p minus q. I need them to match. So am I going to take out a negative m or a positive m? I'm going to have to take out a negative m for it to work. So then I'm going to get p minus q, 9 minus m. All right. Next up, 5m cubed plus 6 plus 5m squared plus 6m. Again, we've got 4 terms. It says factor by grouping. Well, the only thing common to all 4 of them is a 1. So I'm going to split it up into 2 groups of 2. Well, the greatest common factor of the first 2 terms is just a 1. That doesn't seem very helpful. So I need to match that over here, but it's not going to work. So what do I need to do? Any ideas?
Maybe 5 parentheses m squared plus 6. I don't know, I could be wrong.
Tell you what, let me help you out. We're going to take this polynomial and we're going to put it in standard form or descending powers. Okay, see what I did?
Yeah.
Now let's try factoring by grouping. Greatest common factor, 5m, leftovers m squared. Oh, no, it's not. Wrong. Greatest common factor, 5m squared, leftovers m plus 1. So over here, the leftovers should be m plus 1, and I can take out a plus 6, and voila, it works. So now I've got m plus 1, 5m squared plus 6.
Sorry, I'm still trying to take it in. You kind of went a little fast in this one. So whenever we see an expression, like how it said 5m squared plus 6 plus, 5m squared, so forth. So we have to put it in descending order.
Well, you don't always have to, but if it's not working the way it is, that would be a first move, would be to try it. Okay. Typically you do, but not always. Okay, now consider this. Is there a greatest common factor for all 4 terms? What is it?
6 at
I saw an opening bid over there, but it's higher than that. You had a 2 or a 3. What is it?
It's 6.
6. There you go. So we're going to take out the greatest common factor. Okay. But we're not done. Now we're going to look inside the parentheses. I've still got 4 terms. I'm going to try factoring by grouping inside. Okay. So now I'm going to switch to brackets so that I've got, because when I use grouping, I'm going to have parentheses there. So this way I don't get the brackets and the parentheses mixed up. Okay. So what's the greatest common factor of those 2 terms? It would be x squared. So I'd have an x minus 1. Don't look up, look over. What do I need right here? X minus 1. What do I need outside to make it work? Plus 2. So now I've got 6 times x minus 1 times x squared plus 2. There's my final answer. So this one was no different from the ones we did, except there was a greatest common factor for everything that I took out first. Any questions there? All right, so 6.1 has you taking out the greatest common factor as well as factoring by grouping. Okay. I will be back this afternoon from 1:15 to 2:15 at a different Zoom ID. I will, right after class here, I will be posting these videos to YouTube. They should be there in a bit. It takes a while for them to process and everything, but they should be here by this afternoon. Anyway, I'm going to go ahead and stop the recording.